Hello everyone, welcome back. Here's vanAmsen. Today we are diving into tree-based problem, search in a binary search tree. As always, you will find the problem link in the description below, along with code solution in other languages. So let's get started. Here is our task. We are given the root of binary search tree and an integer value. And our mission is to find the node in the BST that equals the given value and return the subtree rooted with that node. If such node does not exist, we return null. If you are not familiar with binary search tree, they are a type of tree data structure with a unique property. So every node left child is less than the parent node, and every node right child is greater. So as you can see, we have 2, 1, 3, 4, 7. So let's check it. So here is 2, and 2 is less than 4. And here we have 1 and 2, and 1 is less than 2. And here we have 2 and 3, and as you can see, 3 is bigger than 2. And same here. So 4 is less than 7, and 7 is on the right. So this is a binary search tree, and we will use this property to solve this particular problem efficiently. So we will begin by defining implementation of our search BST function, so which takes in the root of the tree and value we are searching for. So now let's walk through a step we will take to solve this problem. If our tree or subtree is empty, indicating by root is known, we can immediately return none. And this serves as our base case when the tree is empty, or we have reached a leaf node without finding our target. Next, if the root value equals the value we are searching for, we have found our root node. So we return the root, which is also included in the subtree rooted at this node. But what if the value we are looking for isn't at root? So let's implement it and I will explain. So if root is known, we return known. Then if root value equals value, so we found, we return root. And now it's interesting part. Else root value, if it's less than value, return self search BST root right value. Else return self search BST root left value. And there we have it. Let's run our code and I will explain what's going on. So yeah, it's working all good. So we have found our value. So if the value we are looking for isn't at the root, that's where the magic of binary search tree comes in. If the value at root is less than value we are looking for, we know our target must be in the right subtree because of the properties of the binary search tree. So we recursively call our function on the right child. So this is self-search BST root right. And conversely, if the value at the root is greater than the value we are searching for, our target must be in the left subtree. So we recursively call our function on the left children. And there you have it. That's our efficient solution to search in a binary search tree problem, taking full advantage of properties of binary search tree. So let's run it for unseen test cases as well. So it's my first run, and as we can see, our implementation is quite efficient. It's beat 99.9% of runtime, and also 21% with respect to memory. So all good. And remember, the beauty of coding lies in journey of problem solving, not just keeping the right answer. So keep practicing, keep coding, and if you found this video helpful, be sure to give it a thumbs up, share it with your friends, and subscribe for more coding content and tutorials, and leave your comments in comment section below and any question. And in next video, I will tackle another interesting coding challenge that will help you improve your coding skill. Until then, keep practicing, happy coding, and see you next time.